This episode of Gauging Quality is sponsored by Mahr Federal. Mahr Federal is the application specialist in dimensional measurement. Visit mahr.com to see their wide range of measurement solutions.
Well, welcome to the premiere episode of Gauging Quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest.
And I'm Craig Howell, owner of CPM Labs in Rancho Cordova, California.
Craig here has more than 20 years of experience in gauge use and calibration, which means that he brings that 20 years of experience to you guys to let you know how you use gauges, how you calibrate them, kind of the care and feeding of gauges, everything that you need to know about gauge use and calibration you're going to be seeing on this series of shows. But today, we're going to start with the basics. Today, Craig is going to show us how a surface plate is calibrated from start to finish. Now, if you have any questions during the show, remember, we're live, so send your questions to techno-live@qualitydigest.com. You'll see them there at the bottom of your screen, and we will try to get your questions on the show. It can be questions related to surface plates, what you're seeing today, or it could be some general gauging qualities. We'll try to get to as many of the questions as we can today. So, Craig? Surface plates, this is what we're talking about today. So why is this a good place to start with surface plates?
The surface plate is going to be the foundation of all your measurements. Your tools are going to be on it, the part you're measuring is going to be on it. The accuracy of your measurements will only be as good as your foundation.
Okay. Now, I understand, just so our users know, some of what you're going to see today was pre-recorded yesterday because it takes, how long did it take you to calibrate this plate?
It took about an hour to get this plate done.
Okay. So obviously we couldn't show you a complete calibration, so what we're going to show you is some steps. We'll talk you through it. This was some of the setup things that we needed to do, and then we'll show you kind of a demo of what a flatness measurement is, and also, what's the other measurement?
Repeat reading.
A repeat reading. And what's the difference between flatness? We're going to look at both those things today. What's the difference between flatness and a repeat reading?
Flatness is done on the overall plate. It's imagine two planes, a high and a low, and everything in between. It's a one surface measurement.
And a repeat reading?
Repeat is more of a localized, a 4 or 5 inch section. In this case, a 5 inch section within. So it's a tighter tolerance because you can't have as much variance in 5 inches as you can in 3 feet.
And you have to, this is what's required for an
the federal
official calibration.
spec, you have to do them, you have to do both. You have to do both. The flatness we'll do with our tools, and the repeat reading we'll also do. You cannot do just one and call it a complete calibration.
Okay. So step us through what you had to do yesterday just to even get to the point where we calibrate the plate.
All right. The very first thing we will do is look at the plate and see how level it is. It should be level, and it should be on 3 points. You'll see we're using a master level to see which end's high. They're never perfectly level when we start. So we do it in the other axis also, and we've determined that side is high. So you can see the bubble is pegged all the way to the edge. Now we're going to lift the plate and shim underneath it.
Now you're just using, that looks like a car jack?
It's a car jack. The plate is a little heavy to try to lift and slide a shim under. So we're going to shim it. Now you'll see the bubble is right in the middle. We're level. We're ready to start.
So all you did is you just jacked it up, and I noticed in your bag of tricks you had a bunch of aluminum shims from, looked like maybe a business card thickness up to, what was it?
Maybe a quarter of an inch,
okay.
Eighth of an inch.
So all you're doing is you're just basically just trying to get the plate more or less level as possible. And why is that? Why is the level important?
Ideally, you'd want your plate to be level if you can, if it has adjustments. A lot of times the 3-point setup will have adjusting bolts, or the feet will. In this case, we're on rollers. So the reason we had to be level is our machinery is so accurate, it can only take a certain amount of unlevelness to start. So we have to level it for the actual calibration of it.
Okay, and we'll get to the equipment that you use for. And by the way, how many surface plates do you do during the course of a year?
We'll probably do 3 to 4 a week, roughly.
So you do 150 surface plate calibrations a year or so?
Quite
okay.
a few.
Okay. So you've leveled it. What's next?
After we level it, the next step we would do is we would clean it. We use a combination of a surface plate cleaner to get off all the dirt and grit, and we'll wipe that around, and it eventually dries and cleans off.
And this is just to get off any just general dirt and
General
grime that's
dirt.
on it. Okay.
And then we'll look for smeared metal, which is real common, and that's removing smeared metal that wouldn't come off with the plate cleaner. Aluminum, brass, copper tends to smear on there.
So this is where they've put equipment on there and they've moved it and it's left a residue of the metal behind, right?
That's right. And then we have to clean off our grit because anything will show up. So you can see we had to go back and re-clean
And what is it
areas.
you're using there?
That's called Cratex. It's an abrasive on a rubber compound. It's pretty mild. It'll just remove the material without hurting the granite.
And then again, you had to go back and clean off any junk that you put on as a result of even doing that.
Each time we have to clean. We have to have a clean plate to start. We cannot measure on dirt.
Because the dirt itself will affect the measurement?
It will. The entire tolerance is so close on these things as far as how they're specified. We have to be clean to start.
Okay. So level, clean, what's
After
next?
level clean, we would lay out for setting we're going to put a straight edge and move our levels, so we will lay out the plate as far as where we're going to put position our straight edges.
So tell us what's actually, so here you're marking it up, but what is it you're laying out? Some sort of grid?
It's like a grid where we're going to lay our straight edge and we're going to put the two gauge heads along a straight edge. One of them will stay still, one will move. Right now I'm just laying out the center lines of the plate as well as the edges.
And this is just so you can line up your straight edge later on.
Right.
Okay.
Now I'm getting the straight edge in position. And then next we will be putting the gauge heads right beside them.
Right beside those. Okay. So show us where on a surface plate this grid is.
All
maybe
right.
if we can use the overhead camera, maybe we can kind of see what we're talking about
Sure. I'll
here.
start off with what we're going to do for our reference. Could you remove the amplifier?
Oh, sure. Yeah. Well, actually, let's leave this here for a little bit. I want to refer to this in just a second.
Right.
But you said that you're actually drawing. You're going to do three lines, and just show us where this grid is actually going
All
on
right,
the plate.
I will. It's an eight-line grid is what's specified. And one of the lines goes this direction, then the second one, and then the third. Then we will do three vertical, or three on the other direction. We'll do three different runs.
Okay.
Then we'll do two diagonals. And that will give us our 8 lines that are specified that we should check.
Now, if you had a bigger surface plate, like an 8-foot by 10-foot surface plate, would you do more lines?
We would still do the 8. We would vary our spacing in between each measurement. For a small plate, we do a very, very tight spacing. We'd only move the gauge head a little bit for each one. For a large plate, we might go 6 inches instead of 4.
Okay, so
We've chosen 4 for this.
So no matter what, it's always 8. It's always 8 runs.
It's always
that
8
you're-
lines for the flatness check.
Okay, so we're going to get ready to do flatness right now, but tell us a little bit about the equipment that you use.
Sure, this is the Mahr Federal differential leveling system, and it consists of 2 level heads, which are basically a pendulum, and they will move as the angle changes. That'll feed the amplifier, which has a current running through them, and we'll get a number shown in arc seconds.
Okay.
Then that will go over to the computer, and the software will calculate the arc seconds, and you'll get into that.
Yeah, well, we'll get into the kind of what's actually going on here as you're doing part of your demo. But one thing I wanted to point out is this is I read up on this a little bit. The specs on this is 0.1. It can measure 0.1 or is accurate to 0.1 arc seconds. Like, well, what is 0.1 arc seconds? So I Googled it. 0.1 arc seconds is 28 millionths of a degree. That's hardly
fine measurement.
hardly you breathe on it and it moves. So that's what it's capable of resolving in terms of any kind of shift in level is 28 millionths of a degree. That's pretty something else.
Now, the reason these are differential is there are 2 gauge heads and they're connected together. When we level the plate, we get it as level as we can, but there's always going to be a certain amount of unlevelness. This will compensate for that. If both heads happen to be slightly one direction, by zeroing them in a differential setup, that'll cancel itself out.
Oh, so if you've got a slight tilt to the plate, one measures minus, one measures plus, they cancel each other out, so 0. Okay, gotcha. So the only thing they're going to record is the difference between them. The differential.
Okay. The difference.
I'll get this out of your way.
Well,
and this is the
here,
controller. Okay.
While I'm here, I'm going to go ahead and set up my levels. This is part of what we would do when we're doing your plate. Is I've got to get them both to 0. That's for gauge head A.
So you're just zeroing out the levels right now.
Right. And let's get to gauge head B. both together.
So now they're zeroed out. Now, before we get, also tell us a little bit about what happens on the software over here. Maybe we can share the software screen.
All right. Let me point out what that's showing. What we have is our Moody plot, which is the 8-line measurement that you'll see in the upper right. You'll see the 3 one direction, 3 the other direction, and the verticals. It will be drawing a line as we do our measurement. I'm going to take our first measurement, so it'll start the grid. It starts at 0.
Now, I will say also this has already been pre-programmed with what, the size of the plate and how big each of your steps is going to be, is that right?
Yes, I told you the length of the plate and the spacing of my measurements, which is 4 inches. It does the math. On a 36-inch plate, and we start at 4 inches, and we're going to end at 4 inches in. It says 7 different data points.
Okay,
this direction.
You can just kind of program in the parameters, and it knows what measurements you're going to take and steps you through it. Okay.
So I've done my first one. If we go back to the live, there we go. I'm going to go ahead and take my second measurement. I'll be doing, it looks like 7 of these.
So one level stays in place, and you move the other level 4 inches.
Yes.
Okay.
The B level in this case stays in place. That would be our reference level. That one was, they've both been zeroed, and that stays still. So I'll just take a number of hits here. Each time I do, the machine records the data point. I move 4 inches. I have to let everything settle down. Take my data point, and it draws the line as we go. Just about through here. Looks like I've got a couple more left.
Okay, so I see in the upper left here, that's actually showing you the difference in level, which is also the difference in height as you're moving along.
Right.
Okay.
And the numbers will be both plus and minus depending on how the plate is worn, which direction the level's tilting. This is the final one for this one, and now it shows that path.
Okay, so it shows off, we start off with a little bit of a dip, and then we come back up, and then a little bit of a peak. So we actually are showing a little bit of a dip in that part of the table then.
That's correct. So that's what one path would look like.
Okay. Why don't you do another path, and I'll explain really quick kind of what the math, what the software is kind of doing, just anybody's interested to actually how you're getting a difference in height just from a level. Some really simple trig, and I'll show people what's going on with that.
All right. I'll do another run.
That's assuming I can find my pen, which hopefully is right in my pocket. There we go. Good. All right, if we come up here to our little blackboard here, get some ink in my pen. So what Craig's showing you, so we have our little reference level, I mean the one that stays in place, and that's down here. And we're going to extend the baseline of this. Okay, so on his first measurement, let's say, we'll just really exaggerate, this goes uphill a little bit, and there is our second level. That's the one that we're doing our measurement with. What we're trying to find is that height. Why? What do we know? Well, some basic trig here. You know, if you have the length of any line and an angle, you can figure out anything else on a triangle. So we have this angle. We know that angle because it's been given to us by the level. And we know the length of this line because Craig's already told us. He's doing 4-inch steps. So we've got an angle, we've got one length, now we can calculate y. If any of you remember your trigonometry, sine of the angle is equal to the opposite, which is y, over the hypotenuse, which is 4 inches. Multiply both sides by 4. 4 inches times the sine of that angle. Let's say that angle, just for giggles, let's say that angle was 1 arcsecond. I know that 1 arcsecond is equal to 0.00028 degrees. So 4 times sine of 0.00028 degrees, that is going to give me my height. That just happens to be, if you want to do the math, you can check me on this, about 20 microinches. So over 4 inches with a 1 arcsecond change in level, that is going, y is going to be, this height is going to be 20 microinches, meaning that this point is 20 microinches higher than that point right there. And obviously, he keeps stepping across and doing that calculation over and over again. Or I should say the software is doing that calculation over and over again. So that's basically the math behind it. That's all that's going on. Now, you did another run here. So obviously, yesterday we did all of these and calibrated, and I believe we got results from this. Maybe we can bring up the results of what our flatness run was yesterday.
All right, there it is.
So this is actually this plate.
And there's the 8 different lines, and the word says reference and letter A. That was our first path. That was the one we just showed you now. It took the same shape, dipped down, went up a little bit above. Then you will see on the right side it does say maximum elevation, I believe that's 147, 148 millionths.
Okay.
On this plate, a 2 by 3 foot, there's different grades, grade AA, grade A, and grade B. This was originally made to a grade A, and it meets the spec. The grade A spec was 200 millionths for flatness.
And we measured?
We measured 148.
148. So we are within the flatness spec for a grade A plate. Now, actually, if we can go back to that results screen again, I'm going to ask you a question. You've done a lot of surface plates. You probably recognize different kind of plots. I happen to know how this thing was installed in the shop. I want to I'm going to test you and see. You tell me how it was installed in the shop.
Well,
I noticed this really. Okay, well, yeah, I won't say anything. You just tell me.
I see right by the word reference, it dips down, and also to the left, about the middle on the left, it dips down. So I would suggest somebody was standing or working where it says reference, and they wore the plate in one area, which is habitual. People do that. Always work in the same place.
Oh, there you go. I'll tell you exactly where this was mounted. I got this from a machine shop up near me, up in Colfax, California. This was sitting on a bench against a wall. And so this was the front, and the workman worked on that side of the table. These sides weren't accessible, and neither was the back, obviously, because it was on a bench pushed against the wall. So that was his workspace right there.
So they do recommend rotating the plate every year or so, and that way you can even out the
so you don't keep wearing out one spot.
You're right. So you don't make the dip any larger.
Okay. But even though that was worn there, it's still within spec.
It's well within spec on the flatness. It meets the grade.
Okay. I believe we have a question coming in.
Oh.
If we can get that up on the screen, I'll take a look at it. This is a question from a viewer. By the way, just as a reminder, if you have any questions about what we're doing or anything else related to gauging, send your questions to techno-live@qualitydigest.com. This question is from Joe S. We're moving to a new facility and need to move our surface plate. He doesn't say how big it is, but what things should we consider?
Okay, the two most important things from the surface plate point of view will be the temperature change. You're going to go from a lab environment, usually 68 degrees, into a moving truck possibly, in summer possibly, in winter. It's going to change quite a bit. When it gets to where it's going to need time for the temperature to normalize throughout this granite. It's rock. It does change in dimension as it gets cold or hot.
Okay.
So it's going to need to temperature stabilize. The other is the weight involved. Large plates can weigh tons, and basically they're touching the ground at 4 points a lot of the time.
On their base?
On their base, 4 bolts or 4 wheels, so that the floor will tend to dip down a bit if it's tons.
Okay.
So I would suggest first let it sit in the temperature it's going to be living in for at least 2 or 3 days. Depends how much variance you've seen. We had a company that moved in summer, and it went from a 68-degree lab into a 110, 120-degree truck, and then into a very humid environment to move it into the building. It took a while for the plate to normalize.
So you're saying you need to let it settle literally physically into place, and temperature-wise needs to soak, just like you would soak anything in your
any
calibration
precision
lab.
gauging. Yeah, it needs to sit in the right environment.
Okay, so we've done a flatness measurement. What's next?
The next step would be the repeat reading, and we have a separate gauge that checks that.
Okay.
I'll go ahead and get that ready.
I'll move these out of the way for you.
Now this gauge, we're showing a close-up so you can see the indicator. What it is an indicator on a fixture, and it's going to measure that local variance over a 5-inch span.
Actually, if we can get the wide shot here again, Daniel, I just want to show the whole thing here. Okay, so this is this is called a RON...
Repeatometer.
Repeatometer.
Yes.
Should echo a little bit after that. From the 40s or 50s, I'm guessing.
The design is.
And then you just got a regular dial indicator.
It's an indicator and a 5-inch section.
Okay.
And then there's the base. What it simulates is a gauge block and a height gauge. If you were to move that around the plate, how much variance just due to localized wear would you see?
Okay.
That's the repeat reading.
And let's go back to our close-up here.
All right. Get that set up, and I've tried to zero. What we'll do is move it all throughout the plate and we'll look for the variance, and it's a much tighter specification than the flatness. I'm going to move it some, and we're going to see how it moves. You can see the indicator it moved almost a tenth there. I'm having trouble keeping it on screen, but that's just me.
Now, each of the small ticks is how
20
much?
millionths. So we saw about 80 there.
Okay.
We saw about 80 millionths there.
Okay, so just over that little 10-inch area you moved this, we saw 80 millionths.
Right, that was an area of wear. You know, the inspector that worked at that area was doing his job. He was working.
Right. Now you got to do this over the entire plate.
You're right. We'll follow the similar path that we did with our flatness machine.
And as you're moving it, you're just looking at the gauge and just looking at the deflection on the gauge there.
You're right. I'm looking at the highest high and the lowest low, keeping track. On this certain size plate for a grade A, it's allowed 70 millionths on repeat reading and 120 millionths on grade B, which is the lower grade.
Okay, as you're continuing to move that, we have a question coming in.
Oh, good.
What other methods are employed to calibrate surface plates? That's a good question. So before we had something like a Mahr, the Mahr Federal Differential Leveling System, which is what you use, what did they do?
Previously, I had a planicator, which was basically they called it a straight edge in the spec. I call it a vertical surface plate. It's a very flat piece of granite suspended on 2 points with, again, it had a Mahr indicator on a stick that we would slide under one end and zero it. Very time consuming, very accurate, but you could only do as large as your planicator was. They make them in 2 foot, 3 foot, and 4 foot. We do some pretty large plates, and at times a 4 foot section, you'd be there all day.
Well, I was just going to say, so aside from the cleaning part, do the flatness measurement on this plate took you how long? Just the actual?
It took about 40 minutes. I'd say 35 to 40 minutes for the actual flatness.
And with a planicator?
At least an hour to do a good job, to do it accurate.
Okay. Interesting.
So that, as far as the repeat alternatives, it doesn't matter what brand, several people make them, but they do call out both the flatness and repeatability.
And what was our repeatability?
Total repeatability I saw was 120 million. So although the flatness met the grade A, the repeat was worn to the point of grade B.
Yeah, so what was, for a grade A, what should the repeat have been?
70.
Okay, and
70
we were
max. We saw 80 within our little span.
Okay, and I think you said 120 over the whole.
120 was total, which
so
makes
basically,
grade B.
this is marked as a grade A plate, but so I guess no, we bought this used, obviously. So I guess if you're buying a used plate, which you can get them pretty cheap, this was $200, plate and the stand, but unless it has an up-to-date calibration sticker on it, you don't necessarily know what you're getting.
No, you'll need to have it checked. That's what we do. The good news is they do resurface them. The surface plate companies, we deal with several. Our favorite is Standard Granite. They resurface them to any grade you need.
Okay. Now we have another question coming in.
Okay.
Our plate, no, I don't think we talked much about this. Our plate does not have the 3-point support. What should we do?
The 3-point is the most critical. As I mentioned, when they quarry the rock, they glue the 3 pads on, and all processing is done from that point on 3 points. If it doesn't have the 3-point system, and answer your question, put them on. It's common sense where you put them. You do a tic-tac-toe style grid. You'll put 2 on at 2 intersections and 1 a third of the way down at the other. You'll have 3 different points. It's so the granite it doesn't really sag, but it'll normalize to the right levelness. That's one of the most important parts, is having that 3-point system. Okay. That's more important than level.
And I think we have another question here.
Okay.
And there we go. Okay, well, this is good. I mean, look, we have a desk lamp. The question is, we have a desk lamp near our surface plate to illuminate dark features. Is this a problem? And I've seen this too. Matter of fact, where I was at where I bought this plate, it was kind of a home machine shop, and he had a little gooseneck lamp right over the plate so we could see what he was doing.
The quick answer is yes, that will be a problem. The federal spec mentions if the top of a plate is 2.5 degrees hotter than the bottom of a plate. That's not a lot of difference. On a little 2 by 3 foot plate, it'll bow up enough to show it being out of tolerance with a grade A if the plate was perfect.
Okay.
Just due to the growth of the material.
Okay. Just a reminder, if you got any questions, get them to us, techno-live@qualitydigest.com. qualitydigest.com. There you go. You see it at the bottom of your screen, techno-live at qualitydigest.com. We just have a few more minutes here, but get your questions into us.
All right.
Now, my question came up, and we were talking about this earlier, and I think you had a way to show us, is when we talk, this surface plate has to be accurate within 200 microinches. And the question was, how big is 200 microinches? When we say not any more variation than that, what do we really mean?
Let's do an example where we can show you, because a lot of times we'll be asked, what does 200 millionths mean? What does that look like?
Okay.
So
you need your...
I'll need my levels.
Levels back, okay. This was actually kind of amazing to me.
There's down on there.
There you go.
And can you activate my computer screen? What I'm going to do is get these two levels side by side. I'm going to zero them. All right. So now these are zeroed. Now,
just happen to have a piece of paper
is almost 400 millionths. It's almost twice the entire tolerance we're allowed on this surface plate. This is almost twice the tolerance.
So the question, will the level detect it?
Will the level show it? So let's go ahead and lift it up and put it on there. And we'll see if this happens to show up.
If we go to our screen share there, we can see the actual...
So, well, it showed up.
This is showing 195 arc seconds,
yes.
Which I know from doing the math is about 400 microinches, which you said is about the thickness of a piece of paper. So this paper is actually twice as thick as what the allowable standard is for this surface plate.
You're right, and it would show up. So we can resolve much finer than that. If we were to have put this thing in the finer mode, we would actually see 10th.
Okay, and we have another question.
All right.
Have there been many upgrades or improvements to the measuring equipment that you are using? Have there been improvements over the years? That's a good. When did you get this?
I got that about 6 to 7 years ago. I'd always wanted one.
Okay.
Because these make the job so much more predictable, so much easier from our end. The customers love the graphs. The whole setup works well. Yes, there have been improvements. We started out with the planicator, which limited us to however long the planicator itself was.
And with this, there's no limit really to the size of the plate.
They're 20 or 30 feet long cords, so we do some large plates.
Actually, I'm glad you brought that up. I think we have a picture of one of the plates that you did.
Sometimes
one of the large
we
plates
do some large ones, yes.
Yeah, this one is reasonably large size.
There we go.
So how big is that plate?
That plate was about 13 feet by 13 by 14 feet.
Okay.
I had to walk across it to do my diagonals.
I think you told me that was a grade B plate.
It's a grade B plate.
Which means the total variation of flatness is what across that?
Oh boy. It would be in the thousands on something that large. I don't recall the actual number, but it was well within. It took them 2 forklifts to move it into the facility. It was huge.
Wow.
And when you have to walk across it, you know it's large.
Okay. I think we have another question.
All right.
Am I right? Oh, there we go.
Okay.
Oh, okay. This is good. I've seen this where there are things, I don't know, I guess...
Ledges.
Ledges, okay, clamped to the edge. So does that affect anything?
The plates are made with that in mind. The ledged plates, that's what they're for, is for a clamp. You don't want to be overly aggressive. You don't want to use the C-clamp too hard, but they also, some have threaded inserts, just ways to hold the part down. Sometimes you have to, and yes, you can do that. You just have to be a little cautious.
Okay, we have another question.
All right.
Gauging quality. Okay, what specifications? We've been talking about specs. What are we talking about?
You're right. We're referring to the federal specification, which is, I believe it's GGG-463C. I'm not positive exactly, but that's close.
Those numbers sounded really good. Okay.
It is a federal specification that the plates are manufactured to, and in our case, we maintain them to that, and we certify them to that.
And I believe you said the best or the finest is AA?
AA is lab grade. That's the highest grade. Grade A is inspection grade, and grade B is also called shop room floor or tool room. It's the lowest of the federally accepted grades. Below that, it has to be resurfaced. It can't be certified.
Okay. And the specification obviously changes with the size,
With the length.
with the length of the plate.
Right,
Okay.
a 2-foot plate has a lot tighter spec than a 20-foot plate.
Okay. Were there any more questions there? Oh, we got one other question. Great. Awesome. 1 second there. That looked like the same question.
We could answer it again.
We got time. Are you still getting it? Okay. Well, as he's getting the... Okay, we got it? There we go. What kind of adjustments can you make short of resurfacing the plate?
You really can't adjust the granite as such. It's ground down by the resurfacing process. If it's mounted incorrectly, then you can make a major adjustment, mounted on the 3 points. When we get them and they're on 4-point, right away we say either get a stand with the 3-point or make some cross members. The granite will move quite a bit. And it'll go back to where it was originally processed.
But I believe you did say that you could also have them resurfaced or lapped, right?
They do relap, they do resurface. But this was other than that.
Is that worth doing?
Yes. The granite itself is already stabilized and normalized. It works really well. And when you get a quality outfit that will resurface and do their job right, the plate is better than new.
Do they do it in-house?
They do it at your facility.
Okay.
They travel around and do it. It's a heavy job.
So for instance, this plate obviously is grade A in flatness, but
Yes.
it is deteriorated. It's been worn, so it's grade B. So they could actually bring this grade B now plate up to a grade A.
Or double A, depending. They won't do double A if it's sitting on the floor just because of the environmental changes day and night and day and night. But yes, they can go to any grade you want.
Wow, and they just do it. Okay, great. Do we have any more questions, Christopher? Nope, that's it. Okay, well, great. Well, man, we covered a lot of material today, Craig.
I enjoyed it.
All right. Well, I'd like to thank, before we leave, thank all of you for showing up. But I also like to thank the sponsor for today's show, which was Mahr Federal. Mahr Federal is a member of the Mahr Group, and they've been providing dimensional measurement solutions to fit customer application needs for more than 150 years. The company manufactures and markets a wide variety of dimensional metrology equipment, from simple and easy-to-use handheld gauges to technically advanced measurement systems for form, contour, surface finish, and length. So visit www.mahr.com to see their wide range of measurement solutions. So once again, thanks for joining us. This was a packed half hour. Everything you want to know about surface plates. Hopefully we got to all the questions that you guys had for us. Be sure to keep tuning in. If you got any questions for Craig, if you got something we'd like to cover on the show in future shows, send your questions to techno-live@qualitydigest.com, and we'll get them on to Craig, or we'll consider your suggestions for future shows. So once again, Craig, thanks for a great show. Thanks for your information. Thanks to all of you for joining, and we'll see you at the next Gauging Quality. So long.
Thank you for viewing.